So here we simple learn at the test evaluation. When we are just testing the model, then what is the actual time and space complexity of our k nearest neighbor algorithm? So let's see what actually we have doing in test when we test our model. So actually we have a point xq, and corresponding to that point we are interested to find its yq, that is output. So what we have taken here as an input, if you just remember, as input here we have taken our training data sets, that's we simply discussed in previous lecture, training data sets. And also k means how many nearest point we have to decide to take to consider as a neighbor point for a query point, that is our k value, and our query point that we have taken in general to find the accuracy. We have taken this query point from our test data set. We have to see this thing, and okay, and in generally this is the large dimensional data point. Let's take it is a d dimensional. Let's take, and what is actually output of our algorithms is what? Simple, this output is yq, query point of simple. This is the simple input and output. We have seen this thing in a previous lecture. So in what we are doing at test time, in test time we are finding the k nearest neighbor points. Suppose let's take, I am writing here knpts means k nearest points. I am first I am assuming it is empty. Suppose empty, it is a suppose empty box. It's simple, first assume it is empty blocks, and depends on it is algorithm programming to program which data structures we have to choose for test. If you just simple in general, if you just choose python, it is dictionary format is better to storing this point, because of for finding its optimal time. Okay, so let's take, it's not main method, let's take we have storing this k neighboring point as this data structure. That first it is assume empty box. So now our algorithm says we have run. So for hxi, we have run these algorithms for xi in dtrain. So for a query point, we have to find the distance first. Then according to the distance, we have then calculated the closest k distance. This is the main motto. So to find the closest distance, we have to calculate the first all the distance in our training data. So in training data, we are for hxi, we have in training data, first we are calculated. First what we have to do, first we have compute. First we have to compute the d of distance from xi for h point in our training data to the query point, that is xq. So let's take for this query point xq, compute first for its di. Let's take, we call this di. Then next step, in what we have to do, in next step we have to keep the k smallest from this. Here actually we have, if our data of dtrain is n, then we have computed the n number of distance. Then we have just interest to find the k number of shortest distance from this one. Just we have to sort the k number of sort value. Okay, so k, give the small value, give the smallest k distances okay, and others value we have neglected. Just we have keeping the smallest k values from these t's. Okay, and we are storing this thing as for this form our xi's, corresponding yi's, and corresponding distance di. Okay, suppose here we have taken k means if we have taken k is equals to, suppose if we just taken k is equals to 5. So if we just taken k is equals to 5, then we have to store this 5 number. Among these di's there have n values. Among these di we have to choose 5 small number. So this is actually is the k n points. This is actually the knn point. Okay, this is actually the knn point. Here I have to update this in knn points. So just we have to compute this to find the knn value. So just if you just to see this thing, so how much actual time here required. So for n, suppose let's take our training data set, number of training data sets is n. Suppose let's take, so d train, number of data points in d trains, let's take n. So how much time it is? So here it is have to end, here our end for while loop we have to end. So how much time here we have to running this loop? N time. And you have to compute the xi to xq. So how much time it is taken? Just if you see. So suppose actually just suppose xd xi. So it our training data sets is look like this. Here actually xi transpose, and it is the d dimensional value, and here we have n number of points, and here it is our yi. Okay, we have seen this, our data set is look like this. So if we have a d dimensional point to compute this distance from the n distance, how much time for compute this distance? So how much time it is taken? So to compute this distance, we have taken at least order of d, because we have to actually we have how to find the distances. We have seen in Euclid, if you just consider the Euclidean distance, the find is like that. Summations I is equals to 1 to d x I1 minus ax q query point. We have to find q x I j. Suppose let's take it's j. It's ij to qj square. Actually we have to keep, so we have to take at least subtractions d time, subtractions and square d time. So minimum time actually for each point, actually for each point is take at least order of d time, order of d. Okay, and the keep the small, and we have to find to sort the, if we just store this thing in by dictionary. So the to sort this thing I think is taking order of 1 time. To sort this value we have to take order time. So to order of 1 time. So in generally k is just, we are in typical cases we have taken k is 5 or 10. It is so small number, it is so small. In general, in typically it is a small number. Okay, so it is a small number. So we just let this thing, this to sorting the k smallest distances among these n distances, this is taken order of nd. Okay, for each point, for one point only for training data we have got our time is taken order of d plus order of 1. So we have to run this for n point as well. So for n point how much time it will take? So order of nd time. Okay, this is the first thing in training stage. First we have to compute the knn point for each point, for knn for each query point. Okay, for one query point we have to take this time a1. Now for this query point, for each one query point how much time it's actually take. Okay, in test phase, actually in test phase we have give a query point, and corresponding this query point we have to find its output. And we have seen for one query point we take only order of d times. Okay, after finding the knn, what we have to do? We have to decide this point how much majority vote it has. So in next page we have to find, suppose let's take, we have to find its positive or negative. Now we are simple just running while for while loop. So for each xi in knn, points. Just here we have storing the k number of points. Now we are picking one point from this structure, and from a knn, from these boxes I am picking one point. Okay, each point I am picking, and now see if this point, if for xi, for xi, if yi is positive, for this xi we have also from our data set corresponding yi. If this yi is positive, I think you have understand the thing. We have picking the xi here, also here has corresponding yi. This yi is getting from this data set, training data sets. And if this yi is positive, then we have count positive. We have increased this count positive value. Count positive is equals to count positive plus 1, and initially we have assumed that our count positives is equals to 0, and the count negative initially we have assumed is equals to 0. Okay, if it is positive, then we increase the count positive value, else otherwise we have increased the count negative value. This is the, and then we have ending the our forward loop. Simple. Now we compare count positive and count negative. If count positive, in the next step what we do, we have compare if count positive is greater than count negative, then we can declare that we have returned that our query point of our query output for this query point xq, for this query point xq, for this query point xq, our query output will be 1, that is positive class. Else if it is not, else we return our query point is equals to 0, since it is negative class. Okay, for this step we have to, I think you understand the thing, how actually we have decided for a query point class level from this DNN and KNN, from DTrain and KNN algorithms. So in first steps we have required order of D time, and for counted purpose we have maximum how much time here we require. Here actually maximum value of KNN points is what, k. Here actually we have storing the k points. So this time for this loop, this time is taken order of k value, and in general we have seen that k is small, very small number, k is small. So we have max, if k is small, if k is small, then we can assume this thing is as order of 1. Okay, and if else we have just comparing these quantities, so this time is taken order of 1. So how much total time for this test phase, how much actually for one query point, how much time actually it's taken? So let's see. So actually in test phase, how much time actually it's taking? So the time complexity in test phase is order of nd plus order of 1 as well order of 1. So it is approximately order of 1. Okay, if in general we have see that if our text is, suppose here, just see here, if we have taken the test data set, just all the lectures of the of the all the in this series, all the lectures we have just taking the test data sets. If you just sample using the back of words algorithms, so in this back of word algorithms, in generally for a text, for a general text, it converts to a vector, text we have taken, suppose review vector xq, its dimensions here, its dimension is approximately is 10k approximately, its dimension is 10k approximately. Typically it is not always, depends on, but in average cases, we have seen this kind of dimensions is 10k. In average cases we have seen. Okay, but if there have also some cases, if our d is very small, if our dimension is very small, then or d is very small, from n is very small, then mean average time is order of nd can be written as order of d, sorry, order of n. This is simple the time complexity. If this thing happen, but in general case we are considering the order of nd, test time complexity. Okay, so but the main thing that what is the problem actually, what is the actual problem? So the problem is, it's if you just consider its space complexity, actually how much space actually it's occupied. If you just see from here, in d dimension here, actually just if you just see from here, we have to store how much space. So let's see, suppose actually what is our problem? Our problem is we have a query point, and by using sample this knn algorithms, we are finding its query output. This is we have to do in test phase. In test phase we have to do these tasks in test or evolution phase. Evolutions, as we have to doing these tasks. So but if you see, when you are applying this thing in our training model, actually we are using the whole training data for one test output. We are using simple whole train data. If you just see here just see this stage, we are using for one query point, we are using whole training data, and finds the age, find the output, find the distances from one query point to each pointed in our training data. So if you just think this thing in just if practically, if you just see this thing, just by simply using knn ring, we are want to deploy a model for a company, for a company, we are simple want to deploy a model by simply using knn. Okay, and in such cases we have to for each query point we require retrain data. And in some time, if you just in practical cases, if you see our test data is not something 3000k or 4000k, it's 1 million or it is billion large data sets, our training data sets. So in training, for a one query point we have to find the distances from billion of points. So you can assume how much time actually it's required. And main thing for time, it's how much space is actually required. For one query point we have to store, we have to calculate it, the distances from each training point to one query point. So in RAM, if you just see this thing, in RAM we have to store this whole training data. In RAM or simply in memory, we have to store this. We have to store for one query point, we have to store this whole training data to calculate it, the distance from one point to the whole training data to calculate the distance we have to store. But in generally, the training data point is billion of billion. So our RAM or memory is required so large. So because of its order of ND, we have to store this thing. Okay, or if our D is very small to N simple, it's taken order of N time. Order of or order of N time. It's time taken, and we have to store this order of D means actually here if is order of D dimension, actually we have to store for one query point. Will store order of D. Okay, I think this is a large thing. If you just think this thing practically, because of this space complexity, because of simple one for one query point, because of this this space complexity, in generally we are avoiding this KNN. So we have seen this thing in evolution time. Just if you in evolution time, for example test time, or we have seen our time complexity is order of ND, and space complexity as well order of ND. Okay, we have seen this thing. We have to store for each one query point. We have to store whole the training data. Okay, we have seen this thing. So space complexity is order of D. This thing is a lot time, a huge lot, huge, large. Okay, because of this thing, we can avoid, neglect KNN. Okay, I think in next, if you just think the logistic regressions, so they are simple order of D, we can reduce order of ND, we have reduced order of D only in just if you remember the logistic regressions. So because of that, we can generally avoid that KNN. Okay, I think the intuitions of this lecture is clear, all of you. Okay.